Hello everyone and welcome to our YouTube channel. Today we have an exciting tutorial lineup for you. We will diving into a world of big O notation, a fundamental concept needed in the computer science. A big O notation allows us to analyze and understand the efficiency of our algorithms. So whether you're a beginner or looking to refresh your knowledge, this tutorial is for you. So let's get started. Before we dive into the details, let's begin with a quick introduction to a big O notation. Big O notation is a mathematical notation used to describe the performance or time complexity of an algorithm. It helps us to understand how an algorithm's runtime grows as an input size increase. Understanding big O notation has several benefits. It allows us to compare and choose the most efficient algorithm for a specific problem. It helps us to optimize the code for efficiency and evaluate trade-offs between different approaches. Big O notation is widely used in computer science, from designing efficient algorithms to analyzing system performance. We want to keep our complexity as low as straight as possible, ideally avoiding anything above O(n). So you see this O(n). Okay, now let's move on to a real-time coding example to see how big notation can help us to analyze and compare the different algorithms. Now let's write the constant example. So we are going to write a function which will take an element from array in constant time. So let's write. In this example, we have a function like constant time that returns the first element of array. Regardless of the size of the array, it always performs single operation to access the first element, resulting in a constant time complexity. So this is the fastest way to get an element from array. Now let's write a code in linear time, O(n). In this example, we have a linear search algorithm implemented in the linear example function. It iterates through each element of array until it finds the target value or reaches the end. The time taken by the algorithm increases linearly with the size of the array, resulting in the linear time complexity. So our function depends on the size of the array, this array. And for example, if we have Rn is equal to 1000, so in worst case scenario, we will have 1000 iterations. Okay, now let's write quadratic example. So we have a array function which takes array as an argument, and we iterate each element. So as you see in this example, we have a nested loop structure that prints the combination of I and j values. The number of iterations is proportional to the square of the input. Okay. As n increases, the total number of iterations grows rapidly, resulting in quadratic time complexity. So if we have like 1000, so our iterations will be equal 1000 times 1000. So we'll have 1,000,000 iteration. in this example. Write the factorial exam. Here, the time complexity of a factorial function implemented using recursion. So the time complexity is O n factorial. Let's implement a simple sum function. So the time complexity of this algorithm is O log n. Okay, thanks for watching. I hope you enjoyed. If you found this tutorial helpful, so don't forget to like and subscribe, and leave your comments below. Stay tuned for more exciting tutorials on our channel. Happy coding!